In this episode, we're going to start building the chassis by fabricating the front panel. As well as the rear subframe. These are a good starting point, as it doesn't require a large amount of space or money to make them, and is a good lesson for beginners in marking, cutting and welding steel tubing. The tools used are a MIG welder, a chop saw, angle grinder and various hand tools. For this stage, a very simple jig can be made to hold the tubes in position. One piece of 25 by 25 tube is cut to 440 mm and 1 to 714 mm. The tubes are placed 330 mm apart from outer surface to outer surface, and the longer tube is raised 75 mm above the work surface. The tubes can be clamped in position or drilled and screwed to the work surface. After checking the tubes are secure, central and parallel to each other, the side tubes can be placed up to mark and cut. This is quite tricky as the tubes will need to be angled in two directions and may take several efforts. This one has been trimmed too many times now, so a new one will need to be made. A slightly longer tube will need to be cut now to try again. Using the old tube as a pattern will make it much easier to cut one slightly over size. Once happy, this tube can, as before, be used as a template to make the other side. After which the tubes can be set up for welding. For this earlier chassis, I've set up a similar jig and used clamps, magnet clamps, and what appears to be a suspension arm and hub to secure the tubes. Once tack welded, thoroughly check the frame is straight and accurate. Before adding more spot welds. Heat distortion can be a major problem here, so I tend to build up a series of spot welds and short welds on one join before crossing to the opposite side and working around the frame, with several cooling down gaps in between. And once finished, the frame is thoroughly checked over again and welds ground down. And now the frame can be put aside for the moment. The next stage is the rear subframe. We're going to start by building the top frame. Two pieces of 25 by 25 tube are cut to 475 mm length. You'll also need one piece of 30 by 30 tube and one piece of 50 by 25 tube, which are cut to 450 and 250. The two 25 by 25 tubes are laid flat on the work surface, parallel to each other and 100 mm apart. The tubes are clamped and the 50 by 25 tube is placed centrally on one end and the 30 by 30 on the other. After careful checking, the tubes can be spot welded. Next, 4 uprights are fitted. 2 240 and 2 175mm lengths of 20 by 25 tube are positioned as shown. When happy that all is straight and true, the bottom rails can be fitted. These should be parallel to the top rails and 200mm between inside tube faces and are angled slightly. Next, the lower section can be boxed in using 2 pieces of tube as shown. That completes the outer box, as it were, and the differential mounts can be added now. Displayed here are the Subaru mounts, which are easy to fit. There's some 3 by 40 wide steel strip cut to length, and some 25 by 25 tube with inserts added. This is quite a simple installation, however the Ford differential is a little trickier. 2 brackets are made to fit the front of the differential, and there's an extra fixing for the rear. The rear mounts are made from 2 pieces of 25 by 25 tube cut to 60mm with 2 10mm inserts. For the front mounts, 10mm inserts are added. The centres for the inserts can easily be marked up after the rear mount is fitted. And the top mount goes above. Suspension mounts are next. All the dimensions required are in the build manual. So long as your upper wishbones are around 393mm wide and lower ones 320mm, they should fit. All the suspension mounts can be moved up or down or side to side by 25mm or so. The width measurements are shown here. There are 2 choices for the mounts: to use the original Formula Ford aluminium mounts, which can easily be swapped over or adjusted with spacers, or you can make them out of steel. This may appear quite a daunting task, but once you have one fixed point, the rest flow quite easily. A good place to start is the lower rear mount, which is connected to the subframe by two 10mm inserts. An L-shaped bracket is made from an offcut of 6mm steel angle. The suspension bolt centre is 25mm from the rear face of the bracket. There is also a 10mm thick spacer that sits under the bracket. You'll also see that there's room for inserts and spacers to fit around the rod ends or rose joints. With the rear mount fitted, the exact position of the front can be marked or checked. The front lower mount is a piece of 3x40 steel strip. Extra bracing can be added to the mounts later on. The original alloy mounts can be used. Or steel mounts fabricated. The mounts can be checked to ensure that they are both level and 102mm from the centre line, as well as the wishbones checked for free movement. The upper mounts are angled upwards as shown. In this case, an alloy mount can be fitted via steel mounts. Or a steel mount is easy to fabricate. Here you can see the ends of the 50x25 tube are cut to an angle to match the original wishbones. And here you can see the upper front mounts that are bolted to the frame via 8mm inserts. The upper mounts should be checked that the hole centres are the correct width, and also 280mm apart side to side. As well as for wishbone articulation. Next, the suspension rocker arms can be fitted. These are mounted using 4 pieces of tube cut to 145mm. This will replicate the original setup. The tubes are lined up as per the build manual, or can be changed to match other setups. There's plenty of side-to-side movement available. I've added 10mm to the width of the mounts to allow for spacers and some side-to-side adjustment. These are the original lower alloy mounts. And this is the steel mount that I used. The tube inserts in the middle here are for the Ford differential mount. The coilover and wishbones can be added now, along with pushrod and rear hub. With the coilover removed, you can check for full suspension articulation. I've fitted the rocker arm a little low to aid with the mock-up, so need to raise it by 50mm. Some cross bracing will be added later to add strength. This should work with most rocker arms, or you can make your own. Diagonals are also added using mainly 19mm round tube. It's a tight fit, so these need to be added whilst the differential is fitted to avoid clashes. And on one side there's a removable brace fitted to the subframe by two 12mm tube inserts. This is to allow for the differential to be removed. And here's the completed cross brace for the suspension rocker arms. And there you have the main structure complete. Check all the measurements and tubes for straightness, and take great care to avoid heat distortion when welding it all up. If you can complete this challenge, the rest of the chassis won't be a problem for you. For the next stage, a good flat surface is required. I've combined my chassis table with bodywork buck, which keeps the chassis side rigid and flat. I've marked out a centre line and also the outline of the lower tubes as per the chassis dimensions, and lined up the rear subframe. Two tubes are cut to 1610mm and laid out, along with three 390mm tubes, and tack welded in place. The tubes can be clamped in position using clamps across the table, along with angle and magnet clamps. The front panel can now be offered up and tacked into place, followed by the rear bulkhead. Now the rear bulkhead shown here is for my electric version and has a larger engine bay. If you're intending on fitting a larger engine or motor, then this is the point at which you can diverge from the plan. There's an extra 70mm or so available either side using the standard bodywork. For our purposes, the rear bulkhead is as per the chassis dimensions and this photo. The top tube cut to 564 and the lower one to 440, and diagonals added. The two upper side chassis tubes need to be prepared next. These are 1660mm long and have a small bend of 5 degrees as shown. This can be bent using a tube bender or by heat. In order to mark up the top tubes for cutting, some temporary support tubes can be clamped in place. Carefully check all tubes are straight and true, and then mark up and fit the tubes between the top corners of the front and rear panels. With the outer box complete, the suspension arm mounts and diagonals can be fitted. Firstly, the upright for the suspension mounts, which is fitted as shown. Followed by the other side. The suspension arm, with its bushes and mounts fitted, can then be lined up. The centre of the mounts should be 48mm above the floor. The upper arm centres are 232mm from the floor and will need careful positioning. The top wishbone should be positioned rearwards slightly to allow for caster. The centre of the top wishbone should be around 10 to 15 degrees behind the lower one. Once happy, the upper mounts can be tack welded. A straight tube can be used to check that all the wishbone arms are fitted straight and true. The steering rack can be positioned next. The top bolt hole is about 95mm from the floor. Some sides and a centre support are also added. The upper diagonals are added next. The temporary brace that has been clamped in place here is just the right position to help mount the suspension rocker arm mounts. The tube should be 127mm to the outer edge of the front tube. The bearing can be secured by using a dot punch, and the rocker arm can be tapped on afterwards. The coilovers can be positioned correctly now, along with the lower diagonals and the base plate. For the steering column structure, some 19mm diameter tubes are used. A mount is also fitted for the rear of the steering column, and a tube added for the brake pedals. Components can be fitted, and all measurements should be double checked before diagonals are added. These are 22mm diameter tubes. Round tubes are much easier to cut and fit as diagonals than square tubes in this case. The chassis can now be linked up to the rear subframe. If you are fitting a different engine, now would be a good time to check it all fits, and if necessary, extend the engine bay and chassis. With the subframe and chassis carefully aligned, 4 700mm tubes are cut and lined up for marking, then tacked into position. Diagonals must also be added to the engine bay to finish it off. Components can be fitted and all measurements double checked before the chassis is fully welded. Again, great care is taken to avoid heat distortion. The main structure is complete now and ready for parts and components to be added.